Alright, so in this video, we're going to be looking at this device right here. This is a controller device, and it's hard to see from this view. We're going to look at it through the microscope and it'll be a lot easier. But right here is an ESP32. This handles the Bluetooth and Wi-Fi on this device. And what we're going to do in this video is we're going to put this chip into boot mode and extract the firmware off of it. And this will allow us to obtain the firmware, which obviously is very useful when we want to look at reverse engineering the app. The other ways that I've showed, like using the CH43, I believe that's what it's called, to read the firmware off the SPI chips. I've tried it on this board and it didn't work. So this is another way you can attempt to get firmware if you don't want to desolder those chips. So yeah, in this video, we're just going to go over extracting the firmware off an ESP32, which could be prevalent in a lot of IoT devices. All right, so right here, we just have the digital microscope set up, and we're able to view it through just the Windows camera app. So here we can see what ESP32 we're working with. It's hard to see because of the light, but this is also a -1. That's not as important, but this main part, the ESP32 S3 room, that is what we're going to look up. Because of how popular ESP32s are and how widespread they are, it's pretty easy to find a data sheet online that will tell us what all of these pins do and how we can interact with them. But like in one of my last videos with the UART on the camera, we have these the pads for UART. So we have a ground pad, a transmit pad, receive pad, and then interestingly a boot pad. We'll look more at this in the datasheet of the ESP32. There's also another interface on this board. I'm going to see if I can get it on the camera. And so we're just going to borrow the ground from this one because it's a lot easier to get a ground from something that can accept a pin versus a pad. And this is also because I only have 2 of the probes that will help me to interact with the pads. So we're going to look at how we can hook up the boot because we only have 2 probes. So we're going to look at that later after we look at the data sheet. So here I just looked up ESP32 S3 room datasheet, and Espressif has a PDF here for us. We can see that this is the ESP chip that we're going to be dealing with today. So we're going to just look for the pins. So if we just scroll down, we can look at the pin definitions, pin layout, description, and we're also going to look at the boot configurations. So if we come to the pin layout, we can tell how our device is oriented because of this keep out zone. It's really helpful to tell our device is oriented. So we know, based on looking at the device, we had the ground, we had transmit, and we had read or receive. And then we had this pin. This is GPIO 0. And this pin actually has a special use case. So let's see if we can find it here. If not, I know it's definitely on. All right, so yeah, here it is, but it doesn't tell us anything here. Or that might be the wrong pin. But in the boot configurations, chip boot mode, strapping pin GPIO 0 and GPIO 46, but we're not looking at this one. This one has the pad with the boot on it. So GPIO 0 by default has a bit value of 1. So what we need to do, and it says it down here, we need to pull this bit value to 0. And how we can do that is by connecting that pad or pin to a ground. So we need a ground in that pad. And what that will allow us to do is to put the device into boot mode. And when it's in boot mode, we're going to get a different UART output, and we're going to be able to actually pull the firmware off this device. So I'm going to hook up the device and we'll put it into boot mode, and I will show you what it looks like when we interact with it on UART and what it tells us.
Alright, so here I just have my two probes and my USB to UART. So I know in my previous video I was talking about the tie guard and how it is great for UART and just any serial hacking because it allows you to connect to multiple different serial types. But when I was trying to extract the firmware, I actually ran into problems with the tie guard when trying to extract it from the ESP32. So I switched over to this device and it worked flawlessly. So that's going to be what we're using today. But as you can see, I only have two pads, and realistically, we need to connect to at least 3 pads because we need the boot pad, which is very hard to see, but it's over here all the way at the top where GPIO 0 is. We have our transmit and our receive, because we can hook a wire pin up to the ground. The solution I came up with is this. It looks very sketchy. It's a paper clip with a jumper wire that I just spliced onto it. These will solve all our ground issues. So this is going to hook up to our USB to UART and supply the ground for that, because it's recommended to use a ground that is on the board. And this weirdly bent paper clip actually is bent so that when I put it in this ground, it sits nice on the boot. So it's hard to see here. This is definitely where a microscope is helpful, but it's sitting nice and firmly on the boot. So now we'll hook up our ground here. Actually, we'll hook up our transmit and receive probes first. So this is the probe that's hooked up to the transmit, so we hook it up to receive, and it'll just balance there nicely. And then this is our receive probe here, again hooked up to the USB to UART, and since it's receiving data, we'll connect it right to the transmit. So now I know it looks a little crazy, but so these pads are connected, just want to make sure. And then we just take our black wire and hook it up to our spliced ground that is hooked up to our paper clip. I actually watched a YouTube video where I learned the paperclip trick. These hackers were attempting to hack a Wi-Fi router through UART, and the UART was actually disconnected, so they just used a paperclip to bridge the gap, which is pretty much what we're doing here. So now we're just going to look at us actually interfacing with the device. I just want to give another tip. If you have the power source to this device is connected to the back of it, so it's really annoying if I want to go and just unplug it from the back, because I could move the whole device and it's not really the stablest setup. So just have the power cord near you and just unplug it from its power source, and that's how you can power cycle the device pretty easily.
So here we're back on our Linux machine, and we're just going to make sure our USB to UART is connected. I like using Minicom, and we're just going to look at what the UART actually gives us. So right now we're hooked up to the USB to UART. Our device is actually powered off. We'll just plug it in under my desk. And yeah, you can see here, it says it's waiting for download. So this is exactly what we want to see. But when we go to download our firmware, how are we how are we supposed to do that? So we need to know where in the partitions the firmware is and what other information we want to gather. So actually for now, I'm just going to disconnect the paperclip and then we're going to look at the UART again. All right, so now I just exited out of Minicom and we're going to start it up again. So right now there's nothing, and we're going to power cycle our device again with the paperclip disconnected so it's not in boot mode. And here we'll see a lot of boot up information go by. And if we scroll all the way up to the top to where the device started booting, we can see right here partition table. And then we get labels of the partition table and where they are. So this is really helpful data. We can see the non-volatile storage, the over-the-air data, which is what's going to hold, is going to be what's handling grabbing the firmware when it's transmitted over the air. We have, this is probably where the firmware is, or a copy of the firmware. And then we have the storage with unknown data. So personally, what I'm going to do is I'm going to pull, I'm going to take it all. I'm going to take the whole partition table, which is going to take a while because we're obviously grabbing more data. But once we grab all that data off the device, then we can proceed to chop it up more and break it up into each partition. And it's a lot easier to grab it all and then dice it up versus say I just wanted the OTA 0, but this didn't have what I wanted. So now I got to go back, reset up, and go get OTA 1. Versus I just have it all. I have the offsets, I have the length, I know where the partition begins and ends, and I know where to grab the data from. So we're going to hook our paperclip back up, and I will go over the command where we actually grab the firmware off the device. So now that we have our paperclip back to boot and we're pulling the GPIO 0 pin back down to ground, we can run this command here. So this command uses ESP which is designed to interact with ESP devices like ESP32s. You can use it to flash firmware. There's a lot you can do with it, especially if you're trying to create little devices. Like I know there's GitHub repos where people have made Bluetooth Low Energy hacking CTFs out of ESP32s and little NAT routers that you can use if you want to learn how to hack Wi-Fi. So those are definitely something good to check out to improve your hacking skills, especially if you're on a budget. But looking at this tool, we have ESP tool, and then we tilt the chip, which we know is our ESP32 S3. We're telling it the port that our UART is connected on. So at least on my device, we're connected to TTY USB 0. We're telling it to read the flash, and then we're telling it just to grab the whole partition. We're grabbing everything. And then this is the output file. So if we run this command, it's going to try to connect. You're going to need to power cycle the device here. And once you do that, it will upload the flash and it starts downloading. So, like I was saying, if you want to download everything, it is going to take a while. So, I personally think it's worth it if you're not really doing much. Set this up, don't touch it, and just let it run for a while, and you'll grab the whole flash. And then from there, you can do whatever you want with it because you have it offline and you won't have to really go grab the flash again. So after we have finally downloaded our firmware, which can take a while. We have it in fw.bin, and we can do strings and less, and here we can see what we got. So, I mean, there's going to be a lot of data here just because we grabbed the whole partition. And we can just look through here and look for interesting findings. Um, there's a lot going on in here, so it could take a while to actually find something. And maybe like my next video, I will go over analyzing all this firmware, divvying it up into the correct partitions. Well, what's interesting is in here we have the Wi-Fi information. So we have the um, the TP-Link router that I was connected to, and the password that I actually used. So that's all stored in here unencrypted. This device is also vulnerable to Bluetooth Low Energy. So yeah, we have it again in here so that it can connect. You see there's a lot of things talking about passwords. Again, more passwords and more routers. I was in here a lot actually. Interesting. So yeah, we have that type of info that we can pull off this device. So if you, for some reason, got someone's device, you can pull that information off it. It looks like here we have the firmware versions and when they were installed probably. But yeah, so there is a lot of data that we pulled out of this device. I think I will go over it in another video and we can see if we can expand upon any of this information that we have and if it can help us. Maybe we can write a new firmware, or maybe we just find some secrets and we can attack it comes with a mobile app. Um, so you never know what you might find in here, and we'll look at that in another video. But thank you for watching and stay ethical.